In this video, we're going to talk about slope and rate of change. First thing I want to mention, when you think of rate of change, you probably don't think about a line on a graph. Typical rate of change is how fast I'm going in my car. If I travel 120 miles an hour, I'm going way too fast. But if I'm traveling 120 miles in 2 hours, I might be doing the speed limit on the freeway. So slope is all about how often does something change. In this case, how often does my distance change as I go up every unit of time? More specifically, what happens to my y value as I increase my x value by 1? Okay, so this is the equation I'd want to use. Slope is equal to the change in y over the change in x. And when we talk about this equation, it's change in y all over, once again, your change in x. Okay, we call this the rise over the run. Okay, and if you have a positive slope, meaning that there's no negative side in front of our fraction, the line's going to look like this, where we go up from left to right. A negative slope, on the other hand, goes down as we go left to right. A zero slope looks horizontal, like this, and an undefined slope goes straight up and down. And we'll talk about why that is the case in just a moment. But let's first talk about the zero slope. Okay, why would a zero slope look horizontal? Okay, and remember, zero slope is how does my y value change? Okay, how does it change as x goes from a negative to a positive? And as I move left to right here, my y value is not changing, right? It's consistent. If this were on a y-axis and this were at, say, positive 8, all the way along this line, it's positive 8. So the slope, there's no rate of change, okay? Here's another visual that helps to see where that slope comes from. If I have 2 points, I can simply count off how much does y increase, in other words, the change in y, and how much does x increase, the change in x. So you may have seen this before, but if we use this equation where we label one point as our first point, and when I say we've seen this equation, this guy over here, that's how we figure out the slope. So if I want to find the slope that goes through the points -1, -4, -5, -5, I'm first going to label this x1 and y1, and I'm going to label my second point x2, y2. So when I go to solve my equation, it's going to look something like this, where m is equal to y2. I'm going to try and color code this the best I can, so -5, and then it's going to be minus my y value of 1, which is -4. Okay, I'm just going to write it like this for now, and then do the same thing for my x's. So -5 is x2, and then minus -1 is my x1. That's the equation I need to set up. So we'll have -5 minus a negative gives me +4 all over -5 minus a negative gives me +1. So I have -1 all over -4. So my slope is 1 over 4, and that's my final answer. Okay, let's do another one. The points 4, 6 and 3, 4. I'm going to call this x1, y1, and this one x2, y2. Once again, slope is equal to y2, which is 6, minus y1, which is 6. x2 is -3. x1 is -4. So I'm left with 0 over -7. So my slope is 0. Right? If this were a line, it would take on the shape of something horizontal, whereas my slope for the first one is positive, so it would look something like this. We're going to look in Desmos. Once we finish number 3, we'll revert back to Desmos and see why these lines take on this shape. But one more practice with slope. 4, 6, so 4 is x1, 6 is y1, 4 is x2, 9 is y2. Take it through the same formula. So y2 is 9, y1 is 6, so 9 minus 6, x2 is 4, x1 is 4, so we see 3 over 0, and I can't divide 3 by 0. If you try it in your calculator, you're going to get an error message. Think about it. I can't divide a pizza into 0 parts. That makes no sense. I can divide it into 1 part and I have the whole pizza, but if I try and divide 3 into 0 parts, I can't do it as hard as I try. If I look at this on a graph, it's going to look something like a vertical line. I know anytime I see that, my slope is undefined. Okay, so let's take a look at the lines that are created here. Let's start with the -1, -4, and -5, -5. And we're going to do both of those in Desmos. So once again, my first point is -1, -4. And then we're going to separate this by a comma and do -5, comma, -5. Okay. And I can label this also in my graph. Now, if I were to connect this line, I can see that it's going to be positive. There actually is a way to put that line in. I'm going to hold off for now on doing that. I want to get to the next 2 points. Okay. So my next 2 points were 4, 6. So 4, comma 6. And -3, comma, +6. Once again, if I press enter, where are these 2 points? Well, let's label them so it's easier to see. They're up top. And if I were to connect these 2 lines, it's a horizontal line. But notice why my slope is 0. Does the y change at all? I go from 6 to +6, and everywhere along this line is +6. X can change all at once, but my y is not changing. Because of that, my slope is 0. Let's look at the last 2 points. 4, 6, 4, 9. So 4, comma 6, and 4, comma 9. Let's see what those look like. Okay. So 4, comma 6. I'm going to zoom out a little bit so we can see these. 4, comma 9 in green. If I connect those 2 dots, my x value doesn't change, stays 4, but my y value changes. Okay, it could be 9, it could be 6, it could be 0, it could be -5, but everywhere along that vertical line, x is equal to 4. Okay, notice how the shape of each one of these lines reflects the brief sketch that I drew in the notes. Positive, slope of 0, slope of something undefined. The only one we didn't draw was the slope of something negative, but we'll get to that in a minute. Now let's talk about perpendicular and parallel lines. If 2 lines have the same slope, then they are parallel. If 2 lines have reciprocal opposite slopes, then they are perpendicular. So suppose a line has a slope of -3 over 5. Then any line parallel to line 1 would have a slope of -3 over 5. If line L is a slope of -7 over 2, any line perpendicular to L1 would have a slope of +2 over 7. Notice how I take away the negative sign and I flip the number in the bottom and the number in the top. Suppose a line has a slope of +4. First thing I would do is rewrite this as 4 over 1. Make it a fraction. Any line perpendicular to line 1 would now have a slope. Because it was positive to start with, I make this negative and I flip the 4 over 1 to make it -1 over 4. What's the slope of a line that is perpendicular to the x-axis? Well, anything perpendicular to the x-axis would be a vertical line, right? And we know that that slope is always undefined. What about to the y-axis? Well, any line perpendicular to the y-axis is going to be horizontal, so my slope would be 0. Okay. In these two examples, we're going to determine if the lines are parallel, perpendicular, or neither. So if we take it through our steps, slope is equal to, in this case, 2 minus 8. Right? And let me just label these first, x1, y1, x2, y2. So 2 minus 8 over 4 minus, once again, negative 3. So 2 minus 8 gives me negative 6. 4 minus negative 3 is 4 plus 3, which is 7. So my slope of this line is negative 6 over 7. Likewise over here, we're going to do 5 minus 11 over 8 minus 1. So 5 minus 11 gives me negative 6. 8 minus 1 gives me positive 7. They are the same slope. So I would say they are parallel. Same situation, find the slope. So the slope of line 1 is going to be 2 minus 6 over 0 minus negative 1. So 2 minus 6 gives me negative 4. 1 minus negative 1 is, I'm sorry, 0 minus negative 1 is 0 plus 1. So my slope is negative 4 over 1. Let's try over here. 10 minus 11 over negative 2 minus 2. So 10 minus 11 gives me negative 1. Negative 2 minus 2 gives me negative 4. So my slope is 1/4. Notice how the negative changes to a positive, and the 4 and the 1 switch to the bottom and the top respectively, making these two lines perpendicular. Alright, let's look at a couple word problems. A vendor has learned that by pricing hot dogs at $1.25, the sales will reach 123 hot dogs per day. Raising the price will cause the sales to fall to 101 hot dogs per day. Let y be the number of hot dogs the vendor sells at x dollars each. Find the slope of this linear equation. Okay, the first thing as I would interpret is notice how we're comparing price and dogs, where dogs is my y-axis and price is my x-axis. So I can label each one of these points. This first point, where my price point is a little bit more than $1, and it looks like I'm between 100 and 150. So this price point would be the first scenario, where I'm looking at 123 dogs. My price goes first, so 125, comma, number of dogs is 123. So I'm going to use this as my first point. So x1 is equal to 125, whereas y1 is equal to 123. My second point would be $1.75, and the quantity would be 101. So I can see the general trend as price goes up, the number of dogs I sell goes down. But let's use these 2 points to figure out what my slope is. And I know it should be negative because the shape is going down left to right. So 101 minus 123 all over x2 is 1.75, x1 is 1.25. You can use your calculator to assist you with this. So 101 minus 123 gives me negative 22. 1.75 minus 1.25 gives me positive 0.5. So negative 22 divided by 0.5 will leave me with negative 44. So negative 44, if I wanted to interpret that, what that means is as I increase the price by $1, the number of hot dogs I sell per day is going to go down by 44 hot dogs. Okay, so once again, if I interpret this slope, I have negative 44 over 1, which means as I decrease the price by $1, I sell 44 less dogs. Okay. If we have a linear equation in part C that models this scenario, where negative 44x models the number of hot dogs sold per day, where the price is X dollars each, I want to find the number of dogs sold when the price is 150. Remember, price is your X variable. Y is my unknown. So I would solve this as Y is equal to negative 44 times 1.50 plus 176, negative 44 times 1.5. Well, negative 44 times 1 gives me negative 44. Negative 44 times 0.5 gives me 22, negative 22. Add those together, and I get negative 66 plus 176. Negative 66 plus 176 will give me 110. So that is my final answer. That'll be the number of dogs I sell at a price of 150. Last part. According to my model, how many dogs would the vendor sell if the price was $4 each? Probably not many, but let's take a look. So negative 44 times 4 plus 176. So negative 44 by 4, negative 40 by 4 would give me negative 160. 4 by 4 would give me negative 16. So this would be negative 176 plus 176. What do you know? At $4, I'm not selling anything. My final answer would be 0. And let's go up to our graph and just verify that this works. Notice how my line, when it goes down to 4, when my price is 4, I have 0 dogs, right? I'm looking at this spot right here. 0 dogs at $4, and that just verifies my final answer of